Hello, I am Rose Ivy Bolotaolo, and today I'm going to show you the traffic over my network and also the suspicious traffics. So this could be the user interface of the wireshark network analyzer. As you can see here, the lines are starting to move, and this simply means what type of connection I am using. The local area connection and Bluetooth network connection are both showing straight lines, which means I am not using either of them. In my case, I am using wireless network connection, which is correct since we are using Wi-Fi. To proceed, I will select this network connection and the shark fin, which means start capturing packets. As you can see, there's a lot of packets that is running over my network had been detected. If we look through these packets, we notice that I have a BitTorrent protocol because it's actually running in the background. BitTorrent is a communication protocol for peer-to-peer file sharing, which is used to distribute data and electronic files over the internet. It is most famous as a method for downloading copyrighted material, such as movies and music. So let us try to filter this BitTorrent. So we know that 2.5% of my packets belongs to BitTorrent. And now let's talk about the suspicious traffic over my network. To look for it, let us click Statistics and then Protocol Hierarchy. Wireshark will put all of the protocol and information it understands in a hierarchy structure. If we see the percentage of traffic and the percentage of bytes, these are all the percentage of all the traffics. Under the Ethernet protocol, we notice that 99.6% of packets belongs to IPv4. And under that is the UDP, which is using 52.3%, and the TCP, which is using 44.4%. Both are having a dreaded data, which means that Wireshark doesn't recognize the application that is running over TCP and UDP. So let us filter the packet by typing data. And we can see the list of suspicious traffic over my network. And I don't even know how did it got there. I am also going to show you the traffic on my HTTP protocol. So press Statistics and HTTP, then Load Distributor. As of now, it is not showing any HTTP that is running on my network. So let's proceed with DNS. DNS or domain name system is the reason why when you type in a website like facebook.com, it goes to their IP address. This way you don't have to memorize a bunch of numbers to take you where you want to go on the internet. Whenever you look at a DNS packet, example this, first, we have a DNS ID number to associate queries with the responses, then whether it's a query or a response. So in my case, it's a response. Next is an opcode, what type of query it is. In my case, it's a standard query, and authoritative answers if the response packet is from a name server. Next is the TC for truncation if the response is too big to fit in a packet, and RD for recursion desired, which means the name server will support recursive queries. Z stands for reserved, usually usually set to all zeros, but can be used by the R code field below as an extension. Response code shows you any error. Question count shows you the number of entries in the question section, and answer count as well. And name server count shows you the number of name server resource records found in the authority section, if available. That's all for today. Thank you for listening, and again, my name is Ivy Bolotaolo.